Hi, welcome to toddfun.com, where I share my fun little projects. And what we got today is, you've already probably seen, if you've watched my last video, this is the Arduino frequency counter for the ham radio. It's that video's already been up and you've probably already seen it, but you've seen it in its final box. I haven't even seen it in its final box because I haven't built it yet. But this video, I figure, should be a separate video of how I actually build my box for my little project enclosure. It just needs to be something that this fits in nice and tight, keeps it small, maybe have a little ventilation in case this gets a little warm, has ports on the back for the connections to the radio and the power, and a place for the display. That's it. I just going to show how I do that. Now there's so many ways to build a project box. You can buy a box that's a project box that you can put this in. You can pretty traditional way of doing project boxes is using copper clad board, like you would use for etching for PCBs. You cut it into the size and shapes, and you essentially solder the boards together, and then you drill and stuff, and that looks good too. I have welding equipment, I have woodworking equipment, I have just about everything. I kind of wanted to build something that was light and small, and something that other people could build too, with a minimal amount of tools. I'll probably use some tools that you don't have, but I'm also going to show you tools that I would normally use if I didn't have some of my other tools. So that way you'll have an idea that you can probably tackle a small project box. Soon I'll have a 3D printer. I have one on order. I backed one of the Kickstarter 3D printers in the endless pool of them. And so when that comes, I'll probably start working on figuring out how to print my project boxes or portions of them. I could also go to my local hackerspace, Heatsink Labs, and I could use their laser cutter and make something out of some clear material, or whatever I wanted to cut, even wood. I could do that too, but we're just going to use fairly thin sheets of aluminum. Aluminum's not too terribly expensive when you buy this thin stuff. You can get it at a hardware store. So we'll go ahead and look at the materials here, what I'm going to build it out of, kind of my plan, and then we'll look at the drawing, and then I'll probably just do like sort of a fast sped up 10x 5x something of the different construction pieces, and then of course the end will be the box. But like I said, you've probably already seen the box. Let's hope it looks good. You'll have to let me know. So some of the building materials that I plan on using, like I said, the sheet of aluminum, this is 6 inches by 18 inches. I got this at the Home Depot. It's 21 gauge. Like you saw it already, it's pretty thin, and it's flexible, but it's rigid enough for building a small project box. This cost about $5 to $6. And then for some strengthening of some edges, I've got this offset angle aluminum. It's 4 feet long, 1/16, 3/4 inch on this side, and then this edge is 1/2 inch. I probably won't use this because I'm going to use some rivets to put some pieces together. So I have a rivet gun and a few of these, and most of the pieces are going to go together with the rivets, and then the pieces that have to fasten together, because I want to be able to take it apart and service it or work on it, I'm going to use these number 4 3/8 inch screws. This is about $1, and that'll be what we'll screw into the aluminum for taking the tops and sides off. This, by the way, is about $8. So yeah, if you wanted to buy a project box, you can buy one cheaper than this material. For these little feet bumpers, you get a set of 3 in there for $3, or about $1 per project box. So if you get 3 out of here, you got 3 sets of feet. So that's nice. And then cutting the material. Well, yeah, you can cut this with a hacksaw, pretty easy to lengths. But the sheet, you want to be able to drill in this, and you want to be able to cut out like maybe a window for the display, you know. So for the display, you're going to want to drill the 4 corners, and then you're going to want to cut between those holes. To cut between the holes, or even, you know, to cut an edge and so forth, you can, if you're careful with a air grinder, you can just cut between the holes. I have this little air reciprocating saw, and it's real nice because you can stick it in the holes and then it will guide along on this little guide, and you can cut. You can make fairly straight cuts with this tool. A real fancy tool is sometimes difficult to use, but is an air nibbler, or you can use a hand nibbler. A hand nibbler is where you just do this by hand, and this will actually you can actually put a straight edge on there, and you can make quite a quick cut across something like that. And if you drill a big enough hole for a display, you can cut out your display too. I use this for a lot of quick mods and stuff like that because it's an air nibbler, and a manual one would be harder. There's the trusty, metal shears. They tend to, you got to be real careful not to bend your metal, and of course it doesn't help you much for doing window boxes and stuff like that. For drilling, get a real good set of, well, these are DeWalt's, but a real good set of titanium bits, and of course this is aluminum, it doesn't matter. But try and keep these, if you do any type of metal work, these are really nice. This set has self-tappers in them. Another YouTube channel, Sparky channel, he reviewed these and he recommended them, so I bought them. I'll put a link in my show notes for these two off of Amazon. This whole set is a $23 free shipping, and they're just a great set of bits to have, a good selection. I'll cut through things like butter. We got our engineering paper, our handy dandy EEV blog ruler, so we can do our drawings. We have our project, and what we want to do is decide how long of a project box do we want. We can bake anything we want. We want to decide then how tall we want to make our project box, including this already has little feet on it, so I can include that. Give it a little extra space, and then of course how wide. And the type of box I want to build for this is going to be essentially two C shapes, one like this and one like this, and they'll go together like this. And then the top edges can have some screws, and the bottom edges can have some screws, and that way you just take out like 4 screws, and well, maybe it'd be more than 4, but take out the screws and then the box will come apart, and then this will be sitting in one side of the C, and that way it's easy to just put the top back on. Something else other than the ruler is having some of these veneer variable calipers. I have two. I have a digital one and I have a mechanical one. The mechanical one is simply more expensive and better made. It's a little more complicated to read, but it's really tight. A little easier to read is the digital ones. You get these at Harbor Freight for like sometimes as little as $15 on sale. They do really good. They'll give you in either inches or millimeters, and they do a good job, and you can just read right off the scale exactly what you have in either inches or millimeters. And that's for measuring things like the distance between holes, how wide you want something, how far. It actually becomes easy to kind of get your measurements, give yourself a little bit of slack by going like that, so you don't get too tight on your box. So sometimes these are even easier to use than a ruler. The only thing with these is make sure that you take the batteries out. Don't leave the batteries in these, because even when these are off, they're taking up a little bit of juice, and you'll come back a few months later and there won't be nothing in it. So that's a little pain. That's why I keep a mechanical one. So if I ever run out of batteries, I'm still not out of business. So I didn't use the proper pencil leads and marking. I've done a lot of drafting in my time, but when I do something quick, I just chop it out. It doesn't matter to me. It's not a presentation for any engineering firm or anything. So this is essentially one sheet right here. It's going to have these two folds, and hence these sides are going to fold up, and this will be the front and the back of this container box, and this will sit in the middle of that with the ports cut in the back and a port cut for the LCD. I went a little tall because I had added this salvaged heatsink. You may not, if you build one, you may not care for that, but it did add a bit more of height. So whatever. The measurements I went with were, I just sort of went with, granted, this isn't to scale exactly like this. This says 2.5 and this says 2.5, but obviously this is shorter than this. It doesn't really matter for just drawing something up for fun, because as long as you get your numbers right and you actually put the numbers correctly when you cut your material, that's what counts. So this is just conceptual. Now, this is going to be the top, so the top is going to go down over top, and then just have some screws across the two sides to hold it down. And I wanted a little bit of shape to it, not just a box. So I kind of want it to be like a box with, these are the cables coming out the back, and see if I can hold that up. And so then there'll be, the display will be kind of in the front here, and there'll be a little bit of a curve to the front on this nose. So you get a little bit of a bull nose, a little bit of a shade to your LCD, which is backlit anyway. And it gives it a little bit of fun shape to it. And to get that, I just basically start off with something that's gonna match being able to go over top of this, but I want these folds to be a 0.1 of an inch long on each side so that it does fit over top of this. So that's why this is 3.6. Likewise, I want these edges to be overhanging. So I want the edges to essentially overhang front and back, just to cover up those side edges of the lower box. So that's why I went with 3.2 to be 0.2 longer than this side. And then of course, because I want this to have this bullnose overhang in the front, I went 4 inches across the top where the fold is. And then I'll just freehand a curve when I do my drawing on the piece of aluminum. I'll freehand this curve, I'll trace it, and then I'll mimic it over here, as long as I bend along those edges. So now the next step is to decide about where I want my display and about where I want within this realm my cutouts, as well as what order I want to do the cuts and the bends in, because obviously cutting and bending and drilling holes, you want to do it in a particular order so that you can use your equipment like your drill press and stuff without fussing with pre-bent material. So I want to kind of plan that out. So for the front and back business, we got the display that needs to go on the front panel, and I found some screws in my little screw pile. This is my little screw bin. Whenever I take apart stuff, I save the little screws. And I was able to find 4 that self-tap into this. They'll self-tap into what is essentially the ground plane plated through hole for mounting, and so that's fine. It's the ground plane. There is a possibility that these pins could short on the front aluminum, so I'm going to snip those down short, and then I'm going to put electrical tape all around this edge on the actual aluminum, so that when this bolts in, it won't short out any of this electrical. I've done the measurements here. We'll go ahead and see if we can zoom in. So I have the front, and this is the top, and the measurements I've come up with was for the exact fit of the black. So the black will protrude through the front of the box. That gives me those measurements, and then this measurement and this measurement tells me where to drill this hole, so that I can then, well, I'll drill inside. I'll just draw my lines based on that measurement, and then I'll drill a hole here, and then I will cut out this front piece based on these measurements of the front panel. I'll do this stuff before I do any bending though, measurements and cutting. Now you see there's a question mark circle here, here, and here. That's for those screws. I don't really care where they are, because once I get this cut out, those question marks will be, I'll push this in, I'll mark it, and I'll drill it. And so that's why that's not in importance to this type of a build. A one-time build doesn't matter. Going down to the bottom, this is the back top edge right here. And I need a cutout for the AV cables, this power, and the USB. I always say UBS because of the company I do business with sometimes. So I have the measurements for this. Essentially, this is of course the same shape as the other drawing. I have the measurements to find this dot, this dot, this dot, this dot, this dot, this dot, and that way I can drill in here and then just cut through that drawing. And this is the bend line from that front panel bending. I wanted to have a little bit extra on either side because I don't want any plug-in challenges, and I wanted a little extra height, and I'll have a little extra bottom. So there'll be a big gap here. The reason for this little cutout is I don't want someone to plug into this. So I'll have a little bit of just a little nip out that will cover that up and leave this exposed. I have my drill bit through another piece of sacrificial wood, and that will hold the metal down so that when the drill goes through, it doesn't suck that aluminum up into this spiral bit. I then just push it down tight and drill through. And then we'll be cutting that out on the scroll saw. So a hacksaw would cut fine through this soft aluminum, but I have something faster than a hacksaw, so why not? Now these will be to hold the sides down that come down on the sides. It'll be something to screw into. So we just want to just put them in the middle, but right up flush with the edge. We'll call this 0.1 so we know where they go later. I want to drill some holes. This Arduino has rubber feet, but it also has mounting holes. I want to drill some holes so I can basically hold that firm to the bottom. I'll be using some of these, they're just nylon washers and screws. I get these by the pack loads. But I've noticed something. I put the screen in the middle where I originally had planned to have it near the top. But when I started making my measurements, I thought it would look better in the middle, but I'd already calculated for this distance for the screen being up high, so the screen would sit up here, you know, back into the board a little bit, shortening it a little bit. But then when I move this to the center, well, now this has to be down, and it's going to bump into this. So that means that this has to go back just a scooch, which is fine because there's mostly a hole back here. This is going to get bent up. Except for this cover plate that was covering this power I didn't want to use. Because this has to scoot back a little bit farther, I'm going to go ahead and cut this notch out. Unfortunately, I did all the work to make it, but I didn't make this base long enough. So now we want to cut for the holes for the display. This is the inside with the bending marks on it, and that will drop in there. And we want to basically just mark for these holes. feel we have a fairly decent looking project box, but before we can move forward, we have to temporarily mount the display and then find out where and how we can drill our holes for Arduino. So we have to mark for these stiffening brackets. So I got everything kind of pinched together, kind of where it should be, but these are the brackets that will hold everything together. I will have to just get inside and mark where the back of this is. In there, and I'll put a little line here, and I know that these brackets have to go the thickness of this metal behind those marks. These are going to go in like this, and that will give, so we just have to pop rivet those in so they can be drilled for the front. Number 3. So I'm using these pop rivets any place that I can have a permanent install. I want the fancy looking part on the outside, so I'll push it through here, and that will make the cleaner looking side, and the inside can be the messy looking side. It's a little bit sticks through. I've never used them. And you take your handy little pop rivet tool, and this will suck those two pieces of metal together and permanently attach them. There, I could have probably got away with just 2, but I drilled 3. And see the inside, it doesn't look quite as nice as the outside, and the outside's all going to get painted black, so it should look fine.
Non più tra I farfalloni amoroso, notte e giorno di torno girando, delle belle turbando al riposo, Narcisetto d'amor, delle belle turbando al riposo, Narcisetto d'amor. Non più avrai questi bei panacchini.
So now I got to mark for where I want the holes at, and they're going to be right in the middle of this line here, right here, and right here. Not sure you'll see much, but I'm drilling these holes now. And there are these number 4 38 and 3/8 inch. They're sharp, and they self-tap into the aluminum angle bracket just like butter. They just sock right in. And granted, I'll have to take this apart to paint it, but that'll hold it steady now while I drill the back and everything else. Boy, that's solid. That's not going to go nowhere. It's got this little lip, so
be nice and bright inside its little holder. Everything's, will have rubber feet on it. So I'll take it apart and then spray the inside and then let that dry and then flip it over and then paint the top nice. I don't care how nice the inside looks, but I do care how good the outside looks.
Well, we've painted our box inside and out. Looks pretty spiffy. We have to go ahead and put the stuff in it now. Well, all together now, that's the end of the box build. And just in case, if you don't want to see the build of the frequency counter, there's how it works. Well, that's the end of the building of the box. Turned out pretty good, I think. You can see it working if you watch the other 5 videos on building the actual frequency counter. I'll have using this as the end of that video. This is just finishing the box. I would have to say that if you love building stuff and you really like the challenge, sure, do it like this. The material is a bit too thin, really kind of complicated. A little thicker aluminum sheet would have been a lot easier to use, not quite so easy to bend. I would have to say that it probably took 6 hours of really careful work, and it would be better to just buy a box. If you could measure it up and squeeze it into some other type of box, it would be so much easier. But this is all metal. It'll last a long time. It fits it quite nicely. You got access to everything in the back. You can reprogram it and do some things with it. So it's really nice. For me, I love building things, so it was worth it. But and I'll upload the drawings, which I changed them. So you want to look at the final drawings, because I did tweak it a little bit. And so if you want to build one, fine, that's how I did it. But it's a lot of work. So thanks for joining. Thumbs up for the video, sign up, subscribe if you haven't.